Well, hi everyone. I'm Guzman Calleja, or just Guzman, and I will be your teacher for practices with gate-based quantum computing 2. Um, for this specific chapter that is called Quantum Approximate Optimization Algorithm, or QAOA. We will be looking through it in the next few hours. And thank you for being here. A bit of background on myself. I studied physics in the Autonomous University of Madrid. I'm from Spain. And when I was finishing my degree, I wanted to go a bit into the a more industry focused than academic focused career. So I went into an internship in Accenture. Um, and there I got to the quantum computing team. I was with some of other teachers of this master. Um, there, what I did in my whole internship was developing some optimization algorithm. Um, Always industry focused. That one was about um, optimization for batteries. Um, and after I finished my internship in Accenture, I went to some data and analytics consulting also, and I finished in EY, where I am still. Uh, I've been here for a few years, uh, more than 2 years, 2.5, something like that. Um, and what I do at EY, apart from several um, strategy and let's say a bit less more business focused projects. Um, I've been developing algorithms, mainly optimization ones, and I've also been in contact with stakeholders, trying to getting a bit into also the commercial side, because EY is a consulting company, so we don't just develop algorithms. Um, just as a background of what I've been doing and what I do right now in my, let's say, professional part. I'm also here teaching, so please, every question that you have that may arise when you go through the materials, every problem that you have, please feel free to send me a mail to that direction over there, Guzman CGBA at gmail.com. I would be glad to answer you shortly, and yeah, we can even get together to some session, to some private session to solve the dots if it's easier, whatever you need. So yeah, nice to meet you all, and well, let's start. So okay, uh, what are we gonna see on this class? First of all, a brief introduction for the algorithm. Afterwards, the whole definition. We will have like the definition of the algorithm itself, and also we will have the mathematical definition. Let's say. So we will understand the algorithm, and afterwards we will also see how that translates to a mathematical description. We will see the QAOA applied to the maximum cut or max cut problem. So we will have the explanation, and we will be seeing an example with code that I will be developing with you. And finally, we will see some applications to the real world, or to the or some common business applications, both from the specifically from the max cut problem, but also some for the QA/UA in general. So yeah, let's jump to the introduction itself. So what are the beginnings of the algorithm? So you may have heard that there are some like the mathematics for optimization algorithms come by far in history, but the first time that a quantum approximate optimization algorithm was presented was in 2014 by Fahy, Goldstone, and Goodman. You have the like this is really easy to find in the internet. You can go through the paper. For being a mathematical approach, it doesn't seem to be like so far ago. But those guys were doing that for specific problems. They also in 2014 they published some other paper where they got a better approximation radio than any polynomial time classic algorithm. But it was for a specific problem. In this case, it was for the bounding occurrence constraint problem. But there they had a kind of advantage. So that was very sounded. Everyone knew about it in the community, and but it didn't come back by so much time, because 1 year later there was like, well, you can see there so many authors from New York University, Cornell, Berkeley, Carnegie Mellon, and also from the industry, from Microsoft and the MIT. That came up with a more effective classical algorithm. So from there, now it's on investigation by like so many investigation groups. But you can ask yourselves now, so why are we seeing this if there's like a better classical approach? Or so the same way as other algorithms that you have already seen or that you will be seeing and understanding afterwards. This one can tackle complex and large-scale optimization problems. And this one can tackle NP-hard problems. That means that are intractable for classical computer or classical programming, classical computing, when problem size grows. Although we still have one problem, that is the development of the hardware. So in the moment that the hardware reaches a number of qubits, and also that they are well interconnected and they don't have so much noise, etc., etc. I'm sure you have already seen this one. There will be a moment where the hardware is sufficiently explored and developed that those algorithms like the QAOA and others will be better for some specific problems than the classical ones. So that's why we are seeing them now, and why there are so many people on the developing or investigating how to take the most out of them for either specific problems or in general, because there will be an advantage once the hardware is developed enough. So until now is the introduction. In the next video, we will start with the definition of the QAOA itself and the mathematical explanation for the algorithm. Thank you for watching.